Welcome to another video explaining the particle model. Okay, well, today's video is about sound, and it comes in two parts. The first part is about the particle model for sound, and then the second part is about sound in ether. Now, there are no previous videos about sound that I've ever made. And part of the video is also talks about light. So if you haven't watched EM radiation, that is a good explanation for the particle model for light. So I could recommend that you view that and then come back to this one. Okay, the definition of sound by Wikipedia is that in physics, sound is a vibration. I've highlighted that in red. That typically propagates as an audible wave of pressure through a transmission medium such as gas, liquid, or solid. So sound is a vibration. Well, this is really a neat video. The link to this video is in the description. Just below the title of this video is a description, and you'll find this link there, which is easy to copy, so you can copy it there, click on it, and watch it. If you just stand back and watch this video, you will see these circles start at the speaker and move out just like a sound wave. And that's what we call the sound wave, is these pressure points of the air, which makes the sound wave itself. But if you look very close at any one dot, get real close to the screen, focus on a dot, and watch it, you'll find that it's just moving back and forth, back and forth, back and forth. And whoever put this together was able to make the dots move back and forth, and yet show these pressure points moving out like a sound wave. Great video. Recommend you watch it. So sound in air, sound in solid, sound in liquid all propagate the same way as vibrating atoms, which they vibrate in a certain way that cause these pressure points to move out like a sound wave. Okay, so we have sound from a speaker, and I got this picture from there, and this again, you have the air molecules moving back and forth, but when the speaker pushes out, it compresses the nearby atoms and molecules, and then when it pulls back, it kind of creates an open space. And so you end up with pressure, atoms close together, atoms spread out, close together, spread out, in a sine wave pattern, or in any particular way, whatever the sound needs to be to make it music or voice. And so the speaker pushes and then doesn't push, and creates this motion of a wave that appears to propagate. The atoms that are here never leave here, and the atoms over by your ear never leave near. So it's the same atoms hitting your ear all the time, because they don't move from here to here. But they do something else. They do spread out. You can think of it as if there was a stream, and here's an atom hitting two molecules. The atom black is pushed into the two molecules and causes them to move not in a straight line, but in an angle, some other direction, which causes a phenomenon called spreading. And it's this spreading that causes sound to bend around corners. A plain sound wave, straight sound wave, moving to a slit will spread once it goes through the slit. uh, if it was truly straight. If it was curved, it would spread back here as well as spreading out here. And oddly enough, the air molecules in this slit are just going back and forth, back and forth. Kind of curious. We just don't think of it that way. And of course, here's a sound wave at the side of the wall, and when it reaches it only propagates here on this side because the wall blocks it, but when it gets past the sound, the spreading allows it to go in that direction. Okay, so when you look at today's model for light and sound, they're generally considered different by today's science. Light is an electromagnetic wave, sound is a mechanical type wave. This is an drawing of a EM wave, which moves from source to destination. The vertical red is an electric field that's moving up and down. That's in a it's called a transverse direction because it's perpendicular to the direction of flow. And the blue is a magnetic field moving in and out. And this is one of the arrows for the magnetic field. So this is distinctly different. It's a matter of fields, and yet it moves up and down transversely and propagates from source to destination. And this is just another picture of the sound wave with particles that are moving back and forth, while the wave seems to propagate through the medium, whether it's air, liquid, or solid. These are conceptually different. This is different than that. Well, in the particle model, the sound isn't any different. I'm not telling you anything new about sound. Didn't expect to. So we have exactly the same description here, but when you compare it to the model for light, in light we have G1 particles that are grouped here at a peak and grouped together as a peak, and in the middle there's very few of them. There's a lot of them at the peaks, and the G1 particle goes from source to destination moving at speed c. And that pattern actually can produce what looks like a sine wave. And of course, you have the same pattern here, but here you have particles, here you have atoms and molecules. It's almost like it's at a different level. Well, maybe in the G1, the atoms and molecules are actually in a video that I have presented called Levels of the Universe. G1 particles are at level 1, atoms and molecules are at level 0, sort of a physical level where we exist. The model, the TPM model for light and sound, is conceptually, at least, more consistent, and if it were actually true, if I could prove this to be actually true, it is conceptually more consistent in the sense that this is mechanical motion of particles through space, and this is vibrating atoms and molecules, but all mechanical. Okay, so let's take up a different topic. Let's look at the speed of light for a moment. I pulled up this chart. I'm not going to review that. You can find many of them on the internet. The speeds are in kilometers per second, and I just kind of looked at these numbers and just kind of generalized it that in solids, which has to be something like glass where light can go through, the speed is 1/3 to 2/3 of the speed of c. In liquids, it's more like 2/3. In air, it moves at c. In a vacuum, light moves right through. You can do that in the lab, and you can see light going through a vacuum. A cathode ray tube is an example of light going, electrons or light going through a vacuum at speed c. In relativity, space-time is a medium. They talk about it as a fabric of space-time. Now, somebody may be able to argue that point, but in relativity, it goes through the medium at speed c. And the primary example of bending space-time is a large ball going around even larger ball, and the space-time is bent. So there's something there. But light moves at speed c through that something. Ether, many etherists propose that there is something in space, and it's not just open space, there's something there, there's a medium, and they propose a way for light to propagate through ether at speed c. Well, the medium needs to be just slightly elastic, or mostly inelastic, like iron. I know I realize space is not iron, but it's barely compressible, and if it is slightly elastic or mostly inelastic, the idea is that it can be at speed c, going from the sun to the earth. So that's the speed of light. Now let's look at the speed of sound. Well, sound is much, much slower. It's a lower frequency, and its speed is also slower. In a solid, sound goes, well, there's a whole list of them. I got these range of numbers from this chart. In a solid is 4,000 to 6,000 meters per second. Liquid is 1,000 to 1,500 meters per second. Gas is 200 to 1,300. But in a vacuum in space, we know sound does not propagate in space. But space-time and relativity and ether has a medium. I'm sure that the relativists would tell you, oh no, sound doesn't go through space, and it's zero. But I question that. Same thing with ether. If you ask them, sound doesn't go through. But here's my statement. If the medium can propagate high-frequency light at speed c, then it can propagate low-frequency sound at the same speed. After all, the only difference between the two is the wavelength, is the distance between the peaks. So why shouldn't the space-time in relativity and in ether not propagate sound? Well, to give you an example, make it very clear, hit the inside wall of a submarine and sound will propagate through water to another submarine, and the other sub will hear the tapping, the Morse code, if you will, that is could be sent between submarines. But in a spaceship, if you hit the inside wall of a spaceship, it will not propagate through space to another spaceship. Just to make the same point very clear, space and time and ether must prevent the sound from propagating. And my statement is, if it can propagate light at high speed, it probably should propagate sound. So if there is a medium in space, it needs to be able to block low frequencies and pass the high frequencies. In electronics, this is called a high-pass filter. I'm not an expert in relativity or know what ether really is, so I don't have a solution. But I suggest to the etherists that they need to be able to explain why space-time continuum doesn't pass sound. So the conclusion for this video is the sound wave is a stream of vibrating atoms and molecules with a repetitive pattern. The wave moves, but the atoms just vibrate. The wave appears to, I just said, but the atoms vibrate in place. Light is a stream of G1 particles with a repetitive pattern. It's not an electromagnetic wave. G1s do not vibrate to create the wave. Each G1 moves at speed c and travels the total distance from source to destination, whereas sound, the vibrating atoms stay in place. My name is Bobby Hilster, and I am your particle model guru. Tune in next time when I'll explain more of the universe using the particle model. Thank you for your attention.